One of the trends that has been emerging and is accelerating is distributed manufacturing. So we're hearing a lot more from customers, whether it is a small business or the military, as an example, that wants to have manufacturing in smaller, more modular formats. So Formlabs, we had an amazing 2024. We released two new flagship printers in our stereolithography product line. So the Form 4, which is our desktop machine, and the Form 4L in our benchtop machine, or larger format size. Both have been blockbuster successes, our most successful product launches so far, and we've seen very broad adoption across applications and industries. And honestly, they're very recent. We launched the Form 4 in April and the 4L in October. So a lot of it's just execution and educating the market that we have the next tier solution available. They're 2 to 5 times faster than their predecessor, and they're much better suited to large scale production. And so a lot of it is having conversations about using stereolithography instead of traditional injection molding. What we're hearing from customers, I'd say one of the trends that has been emerging and is accelerating is distributed manufacturing. So we're hearing a lot more from customers, whether it is a small business or the military, as an example, that wants to have manufacturing in smaller, more modular formats. And so for a small business, that's kind of just what they do, right? They don't have the need to print 1 million parts. They might want to print 1,000 or 10,000 parts. And because they're a new business or a smaller business, they're interested in additive being the way they produce their end-use parts from the beginning, as opposed to having to change from traditional to additive. And we're seeing an acceleration of that, especially with our new products that can do higher volumes of end-use parts. And then the military application, it's a bit different, but it ends up being modular manufacturing anyway, which is an example where military customers want to deploy our powder-based system, our fuse-based system, in the field. And so they want to have manufacturing can do at the point of need, and that could be distributed into small cells of 3 to 4 printers, it could be up to 8 printers, or it could be 1 printer in each location. But the theme really is having distributed, more modular, and kind of small cells of production. What Formlabs is doing a lot to help customers with distributed manufacturing, I'd say one is just product innovation, right? We just released 2 new flagship printers in stereolithography, which have a much higher level of reliability and throughput, and so that's core to doing distributed manufacturing. And then we also have been doing a lot of continuous development and improvement on both SLS and SLS by using customer data to improve reliability and uptime. And that could be refining our print settings, that could be introducing new software features, and then it also bleeds into customer service. We've invested in improving our customer service and reducing the time to resolve customer issues when they come up. Because inevitably, even if your machine is excellent, extremely high reliability, customers are going to face challenges, and you have to be there for them when they need it. And that's particularly true when they're distributed manufacturing, because they have a small cell where they're really banking on you to deliver. And so the level of customer service you have to deliver is structurally higher. The skilled labor gap, I think of 2 things when I think of additive. And one, I'll say I think Formlabs we're doing very well. And one, I think we need to invest more and probably improve. One we do very well is ease of use. I think when you think about skilled labor, it sometimes implies that what you're doing in manufacturing is very hard to learn and it takes a long time. One thing we pride ourselves on is building an end-to-end ecosystem with hardware and software where you can go from a part file to a finished part as easily and simply as possible, and people can genuinely learn both of our systems in 15 minutes or less, and we get that feedback from customers all the time that they're excited about that. And as we brought out our new generation of printers, the Form 4 and the 4L, we've made that even easier. So I think that's where we're strong, and I think that helps the skilled labor gap because the bar for skill is not as high to get into it and produce great parts. I think where we need to invest more and the industry needs to invest more is in automation. I think that's the other part of the skilled labor gap. The more manual it is, the more bespoke, the more custom, the harder it is to scale something. And so all of us, OEMs and additive manufacturing can bring end-to-end automated solutions, and that will reduce the threshold for the level of skill and labor and also increase efficiency and therefore drive down the total cost per part, and that drives broader adoption. I'll be honest, I think additive is suffering from a execution issue to some degree. We have, unfortunately, a large number of businesses that don't have a strong backbone of their business model, don't have strong unit economics. And in any industry, it's not unique to additive, that doesn't really work. That's not going to lead you to success. You have to deliver a lot of value for customers, and then you have to be able to capture that value and run a sustainable business. And so I think, consolidation when you have poor economics is just kind of the natural law of business. It'll happen in any industry. And so I would think about it as any company in additive that has strong fundamentals of great customer value and they're running their business and executing really well and responsibly, they have the opportunity to succeed. And that's true for other industries as well. I think one of the places I'm most excited about AI for additive is in making the process to design parts easier. I think that's a barrier to adoption. Having people have to learn CAD and advanced CAD is a barrier. It's definitely part of the industry and something we have to acknowledge. And if you don't have a digital part, you're unlikely to be able to produce a part using additive manufacturing. And I've seen some amazing technology coming out already where you can do text to an image to a 3D file, or you can do a drawing that turns into a 2D image that turns into a 3D part file that you can print. And the advancements are happening fast and furious. So I'm very optimistic that the AI software companies are going to make the process of going from an idea to a 3D file infinitely easier, and that is going to enable broader adoption of additive manufacturing. Now, is Formlabs doing that directly? We don't really talk about our R&D. What I can say that we do in our existing products is use artificial intelligence and algorithms to make the process as easy as possible. So we have one feature in our software that is a good example of this. It's called one-click print, and it allows you to set up and orient and support your structures in one click using an automated solution and have a very high reliability that you're going to get a great part that is prints successfully. And that's just one example of how we use AI and algorithms to make the end-to-end process very easy and reduce the threshold to be able to use additive manufacturing. I think industry standards for additive is a big opportunity, and honestly, I haven't seen a ton of exciting progress. At Formlabs, we're trying to be a leader in this space in a couple areas, and we'd love more people to get on board. One example is reliability. We actually commissioned a third-party study of our latest desktop SLA printer, the Form 4, to benchmark on print success rate. Just when you start a print, do you get a successful part out the other end? And we commissioned that study and benchmarked against some unnamed competitors to just start establishing a standard for how to talk about reliability. But as far as I know, we're the only company that's done that. And so we'd love to see more adoption around a simple metric like that, print success rate, and people to agree on a standard for testing and to use independent third parties to test different printers and benchmark them. Another place we've been learning a lot where I think we could also collaborate more is around material properties. So we actually had a breakthrough, one of our newer materials recently, our tough resins for SLA, where we figured out that the traditional material properties weren't really characterizing what the customers needed quite right. Our materials are very strong, very tough under the traditional tests, but when you initiated a crack with by damaging the part or cutting it, the crack would propagate really fast. And so we actually had to develop and look for other tests that would better replicate this failure mode. And then we reformulated our resins to address that. So now the new material, the cracks don't propagate. And so if you drop the part on the floor, you chip it, you damage it in handling or operation, it's much more robust. But once again, as far as I know, we're the only company testing to that standard. And it took a lot of R&D to even figure out how to address the problem. Post-processing is huge, and I would love everyone to spend more time talking about it, because if you think about barriers to adoption, post-processing being hard is one of the biggest barriers for additive manufacturing. We also spend a lot of R&D and effort trying to make post-processing easier. We actually, a couple weeks ago, released a new curing unit for our Form 4, which is way faster and way easier. So cure times used to be from 15 minutes to an hour. We brought them down to 60 seconds to 10 minutes, including our biocompatible and engineering grade materials. And so this is a leap forward in ease of use and making the cycle time much shorter and much easier to get a great part. But honestly, it's not something that's talked about in the industry a lot. People herald new printers. They very rarely get excited about new post-processing technology. But we are excited, and we're innovating there, and we're delivering more value to customers as a result. Yeah, honestly, I think additive is following a kind of well-documented cycle. I think it's called the Gartner hype cycle, where you have this like bubble of expectations, then there's kind of like the bubble pops and it comes down, and then you start to move up and figure out what the technology can really accomplish. I believe that stage is called the slope of enlightenment, which I think is quite hopeful, and that's the way I feel about additive. Is yes, we went through a hype cycle, the bubbles burst, and now we are learning what applications additive is really great at solving and what problems we can conquer with the existing technology, as opposed to kind of forecasting what might happen in 10 years. We're focused on the here and now, and there's a ton of really challenging problems that we can help our customers with, and so we should be able to build great businesses. One of the applications that has really hit us in the face in terms of customer demand is drones. And I think drones is a great metaphor to think about where additive is successful. So drone customers are coming to us and mostly looking at our SLS powder-based line, the Fuse printer, as a great option to produce their end-use parts. And why is that true? Additive is great for drone applications because components have to be lightweight, and additive is great for lightweighting. A lot of drone manufacturers tend to be new or emerging businesses, so they're interested in new technology and doing things with additive as opposed to transitioning from an old technology to additive. So it means they're faster adopting. And then you can also deliver a very competitive cost per part, because the part count for drones tends to be in a range where additive is the most cost-effective solution. So you have this swarm of different factors that means there's a ton of demand from customers, and we're seeing that in installations of 5 to 10 of our Fuse printers, just printing drone components all over the world for military, non-military applications, and we're seeing the form of some of our most successful marketing. We had a webinar recently, which is our biggest SLS webinar ever, because it was about drones. We had more than 1,000 people register and attend because there's this wave of interest in how to use additive for drone manufacturing. I love this question about best practice sharing because I also think it is an opportunity. We think a lot about education and customer service as core to what we do at Formlabs, and it is our responsibility to not only make the kind of standard workflow work well, but when you run into a problem, you can get your questions answered really quickly. And I'm excited, we're investing in a separate YouTube channel from our current Formlabs YouTube called Formlabs Support, where we're going to make amazing quick videos where people can self-serve and figure out all those tips and tricks, best practices, how to do repairs, how to replace parts, and anything else they need to know about our technology. And I think that's really what we need. When we think about when we run into a problem at home or in other parts of manufacturing, a lot of times people go to YouTube. And I think we need quick hit videos that are relatable, that allow you to solve your problem quickly and get back to manufacturing parts. I think it's important, honestly, any show where we bring together players in additive. I also like ones where we talk to people in traditional manufacturing, but the biggest part is talking together with our customers. All the value we create comes from the customers, and so this is an amazing opportunity to get immersed in their needs and really understand them deeply, how they differ between different applications, where we're disappointing them and need to do better, where we're really thriving and we need to lean in. And I think sharing that across companies will help us drive broader adoption of additive across the whole industry. We look at Keyence a lot as a company we admire that's in the manufacturing and hardware equipment game. They're a global company, and one of the things they're known for is having an amazing sales force. And so when we're talking about a trade show like this, if you ever go by a Keyence booth at a trade show, you will know the power of their sales force. They immediately come up and talk to you and demonstrate their technical expertise and start figuring out how to solve your problems. And they're there on a mission to help you do that. And it comes across very clearly in the way they operate their booth. That's just one example of a company that you can learn from and emulate because they're just amazing at sales. So there are some innate benefits of additive manufacturing for sustainability. I think one easy thing to do is just to market and communicate those benefits better. In the current macroeconomic climate, it's probably a good time to lean into that because people are adjusting their supply chains and changing their mind about how they should set them up. And additive is really good if you want to produce locally, right? If you want to produce at the place that you're shipping and delivering to customers, additive can do that and be very cost effective. And also in the process, it's going to be more environmentally friendly. And so it's a great time for us to just take advantage of kind of the chaos that's happening in the world and tell people they can actually lean on this as an opportunity to make their manufacturing more sustainable.